Hello friends, Namaskar. Welcome to CEC Live Lectures. I am Dr. Pavitra Bharadwaj. I am Assistant Professor of Computer Science in Jesus and Mary College, University of Delhi. We have been discussing computer networks in our present series of lectures, and this lecture will be the 9th lecture in the series of computer networks. So we have been, talking about multiple aspects related to computer networks. We have talked about the, components of a network, what comprises a computer network. We've talked about the different protocols. We've talked about the architecture of the internet, how the internet functions, right? And then now we are talking about the different components of the different layers of the TCP protocol. So we had seen, that the first layer of the TCP IP protocol is the physical layer, right? So on the physical layer, we see that, below the physical layer is the 0th layer. So if we say that the physical layer is layer number 1, so below this also we consider that, there is a level 0 or a layer 0, which is actually the transmission media or the hardware. So some models, they consider hardware also as a part of this layer. But, generally we consider that the TCP model consists of 5 layers and the physical layer is the first layer. But nevertheless, transmission media and its role in the overall composition and functioning of a computer network is very important. And we had discussed about, the different types of transmission media which are available for, connecting computers or connecting devices over a network, right? So if we just quickly, go through what transmission media means. So basically, this is something which is located below the physical layer, as I already said, and this is directly controlled by the physical layer. So directly controlled by the physical layer, we mean that the physical layer has got data in the form of bits and bytes, that is zeros and ones, right? And then the physical layer, the data which is transmitted on a transmission medium, whether it is a wired medium or it's an optical fiber or it is any other medium for that matter. So these bits have to be converted into, say, electronic pulses, or they have to be converted into optical signals. So this data has to be converted from the logical format, that is from the bits and bytes, to real signals which are actually going to move or actually going to travel on the physical media, right? So in this, transmission media, basically we define it as anything, which can carry information from a source to a destination. So transmission medium could be your air, it could be a written message, okay, it could be mail carrier, it could be truck, or it could be an airplane if you are talking about non-digital communication. But when we are talking about digital communication, or when we are talking about data communication, then we are more specific. We will say that transmission medium is basically free space, or it will be a metallic cable, or it will be an optical fiber. So anything, any medium which takes the data from one source to another destination is known as a transmission medium. Now the information which is, of course, it is converted into a signal. On a transmission medium, the data is going to flow in the form of a signal, right? So this result of a conversion of data from one form to the other form is done at the physical layer of the TCP/IP protocol suite. So in the last lecture, basically we had talked about two types of transmission medium. We were talking about the guided and unguided transmission medium, and in guided transmission media we had talked about three main types of medium. One was the twisted pair cables, we had discussed the coaxial cables, and we had discussed the fiber optic cable. Now we are looking at another category of transmission media, which is the unguided media, or we can also say that these are the wireless networks, right? So guided basically meant that the data is going to move, or the data is going to flow on a particular path, on a predefined path, and that is a constrained path. When I am saying that a wire is connecting one computer with the other computer, and then the data will only flow through that path or through that wire which is connecting the two computers, right? Whereas in case of wireless, where we are using waves, different types of waves to transmit the data, then it can be a different scenario, because then there is no specific path or there is no closed path on which the data is going to move. Then it is actually traveling in free space. So this is the major difference between guided and unguided, or between wired transmission media and between wireless transmission media. Of course, there are multiple pros and cons also to this that we need to understand. So in the previous series previous lecture we have talked about the advantages and disadvantages of the three types of guided media, and which of these is best suitable depends upon the requirement and depends upon the cost, depends upon the architecture of the network, depends upon the speed which is required, depends upon the security aspect or information security aspect, what is expected of the network. So keeping all these factors in mind, the data network administrator will take the call on what media to use. Most of the times we see that it is a hybrid network which is created, which uses multiple types of more than one type of transmission media, particularly when we are talking about wires. So it is more than one type. Even in wireless these days we see that networks work in a hybrid fashion, where some part of the network is wired and some part of the network may be connected through wireless connection. So all these possibilities they are very much there when you talk about building real life, real time network. So we cannot constrain that a network will be only wired, or it will be only wireless, or it will be only a fiber network, or it will be only a microwave network. They generally what is happening is that a lot of intermingling of technologies is happening, intermingling of tools is happening to build real time network. So now we are going to talk in detail about the three types of wireless networks or unguided networks, which are basically taken care by radio waves, microwaves and infrared. Besides this, besides the waves, and there is another category of networks which is very, very significant and which is gaining more and more momentum every day as we are moving towards 5G and very high speed broadband internet connections, that is the satellite network. So definitely we will also be looking at the satellite networks and how they can be used to build the computer networks. So if we talk about the unguided media or the wireless transport media, so here there is no physical conductor, there is no wire basically, therefore it is known as a wireless communication, and signals they are generally they are broadcast through free space and are available for anyone who has a device capable of receiving them. So it's not a physical contact, but it is the signals are freely moving in the space and any receiver can receive the signal. So this is basically a more open kind of a connection that we are looking at. Now unguided signals, they travel from the source to the destination, and there are three modes in which the signals can travel. So there can be ground propagation mode, there can be a sky propagation mode, and there is a line of sight propagation mode. So there are three main modes in which wireless data it moves. So first let us see if you talk about the electromagnetic spectrum. Okay, so in the electromagnetic spectrum we have waves in the range of 3 kilohertz to 900 terahertz. So it's a huge spectrum in which different wavelengths of or different waves, different kinds of waves of different wavelength are available. So of course after 400 terahertz is the light wave. So we are not looking at that because we have already discussed how data can be traveling, or how light signals can be used to travel to communicate or to send data from a system to the other. Here what we are looking at is, we are looking at the radio wave and the microwave signals, and we are looking at the infrared frequencies. So we can see that infrared frequencies are very high frequencies. So they are 300 gigahertz to 400 terahertz, very high frequency waves these are. And of course, you have radio waves which are lower frequency, and in microwaves which are more than the radio waves but less than the infrared frequencies. So, if we look at the propagation mode, so there are three propagation modes as I just explained. So, first is called the ground propagation. So, ground propagation basically is used for waves where you are using communication frequencies up to 2 megahertz. Then we have the ionosphere communication or propagation mode, where we are using in the sky propagation basically. So, in the sky propagation we are using the frequencies 2 to 30 megahertz, and then we have the line of sight in which we are using above 30 megahertz frequencies, signals of above 30 megahertz. So, as the name itself suggests, so in ground propagation basically there are radio waves that we are looking at, and these radio waves, they travel through the lowest portion of the atmosphere, almost they are hugging the earth. So, these are basically low frequency signals, as we have already seen, up to 2 megahertz. So, these signals are low frequency and they emanate in all directions from the transmitting antenna, okay, and they follow the curvature of the earth. So, we all understand that the earth is not a flat surface, it is curved surface. So, whenever a signal is flowing, so it has to flow through a curved surface. So, the distance, how much a signal is going to travel will depend upon the power in the signal. The greater the power, the greater will be the distance the signal can travel. So, it is basically radio waves which are used which use this ground propagation mode. Then we have the second type of propagation mode, which is known as the sky propagation mode. In sky propagation, you have higher frequency from 2 to 30 megahertz frequency radio waves which radiate upward into the ionosphere. So, what is ionosphere basically? We know that the Earth's atmosphere is divided into multiple layers which are known as strata sometimes, or they are known as spheres, right. So, one of these layers is known as the ionospheres, because this has got particles which are actually called ions. So, these are charged particles which are known as ions. In chemistry and all we study about anions and cations. So, ionosphere is the layer of the atmosphere which contains charged particles called the ions. So, and these when the ray waves go to these ionosphere, they are reflected back to the earth. So, this type of transmission, it allows for greater distances with lower output power. So, the distance travelled is more and the output power is actually less in this case. And then the third type of propagation is the line of sight propagation. So, again we know that very high frequency signals are transmitted in straight lines directly from one antenna to the others. Now, we are saying line of sight, why? Because as we already seen that the surface of the earth is curved. Now, due to this curvature, there is a limit up to which the the line of sight can be there. So, line of sight means that two antennas which are exchanging signals, they have to face each other, right. So, they have to be directly in each other's line of sight. Now, how can that be possible? Either you place them very close to each other, right, so that they are in front of each other, they can directly communicate, or your antennas are really tall, right, so that they are not affected by the curvature of the earth. So, line of sight propagation is basically tricky, because radio transmissions they cannot be completely focused, because when we talk, we will be looking at the radio waves. We know that a radio antenna is going to propagate signals in all the directions. So, therefore, this type of communication will not be very feasible for waves basically. Now, we first talk about the radio waves. So, now when we talk about the radio waves and the microwaves, so we have seen in the electromagnetic spectrum also that there is not a clear demarcation as in where the radio waves end in the spectrum and at what frequencies the microwaves start. So, we say the total range of frequencies for radio and microwaves is 3 kilohertz to 1 gigahertz. So, these are normally called radio waves. Now, waves which are ranging in frequencies between 1 and 300 gigahertz are called microwave. So, up from 3 kilohertz to 1 gigahertz are radio wave, from 1 gigahertz to 300 gigahertz, they are known as microwaves. So radio waves for most part are omnidirectional. By omnidirectional, what we mean, that when an antenna is transmitting the waves or when an antenna is sending the signal is being sent in all directions. Unlike line of sight, where we say that the signal travels only in the straight line, here it is not like that. In this case, the signal is also going to travel in all the directions, right. So, the signal is basically, the waves are basically propagated in all the directions. So, therefore, there is no need for the sending and receiving antennas to be aligned or to be in the line of sight of each other. So, sending antenna sends waves that can be received by any receiving antenna. Because it is transmitting, the waves are moving, are propagating in all possible direction. So, this omnidirectional property of radio waves or the antenna has a disadvantage also, because we are saying that one antenna can transmit rays in all the direction, radio waves will propagate in all the direction. So, the radio waves transmitted by one antenna are susceptible to interference by another antenna that may send signals using the same frequency or band. So, if we are two antennas which are, of course, they are not in the same line and they are sending the signals at the same frequency, then there can be interference, because the range up to which radio waves are propagating is quite high. So, they are moving in all the directions and they are moving with more power. So, it is very susceptible to interception, unwanted taking up of the signals by certain antenna, and radio waves, particularly those waves that propagate in the sky mode, they can travel long distances. So, this makes radio waves a good candidate for long distance broadcasting such as AM radio. So, radio waves are basically used for sending the signals over for longer distances, because they can move up to larger travel or larger distances without much need of being amplified. So, if we look at this picture, this clearly shows the omnidirectional antenna and how the waves are propagating in all the directions around the antenna. So, radio waves basically these are low and medium frequencies and they can penetrate the walls also. So, this characteristic again because of the low frequency, they can penetrate walls or buildings, but this has got advantage and disadvantage both. Now, how is it advantageous? Because we can listen to a radio even when we are inside a building, the radio signals can penetrate the wall. So, we can listen to radio signals or radio, AM radio or FM radio, whatever, on inside the buildings also. But at the same time it is also not possible to isolate a communication or to just inside or outside a building. If you want to tap the communication, whether it is happening inside or outside a building, that cannot be done, because the waves can penetrate the walls and the movement is similar to the way it happens outside the walls also. So, therefore, radio wave band is it's relatively narrow, because we say it's under 1 gigahertz compared to the microwave. Microwave is 1 gigahertz to 300 gigahertz. So, here this band is divided into sub bands, and the sub bands are again narrow because it is only up to 1 gigahertz. So, leading to low data rate for the digital communication, right. So, radio waves are therefore not commonly used for data communication or for digital communication. They are generally used for AM radio and things like these. So, and these another important thing is that although the band is low, it's a narrow band, but still it is regulated by authorities. It's the authority or it's the government or some allied authorities which you have to seek permission in order to use these frequencies. You cannot use the radio wave frequencies without the permission of the authorities in a specific region. Now, again, applications, radio wave, as we just discussed, that radio waves have their omnidirectional characteristics. So, they are very useful in multicasting. Multicasting basically means that when you have one sender and you have multiple receivers. So, it is very useful because these waves are low frequency, they have high penetration rates, they have they can move longer distances. So therefore, this is an ideal candidate for multicasting messages, and this is very commonly used in AM and FM radio. It is used in television for telecasting. It's used in maritime radio, cordless phones, paging, and there are multiple other examples where radio waves are used very commonly. But definitely for digital communications, radio wave are not, the channel of choice. Generally we use the other formats of communication, maybe the infrared, or maybe we will talk about the microwave, how these are used. So we will be talking about the microwaves later in the next part of the series. Till then, thank you.